Nowadays, we spend much time on the internet. Whether we save our personal data, watch videos, shop, or work, we rely increasingly on the internet. Since we make use of the internet a lot, it's extremely vital to protect our information. Data encryption is one of the methods of securing information on the internet, and it's also one of the oldest and most widespread methods. When discussing encryption, we cannot exclude DES. What is Data Encryption Standard, DES? DES is short for Data Encryption Standard. There are computers that exist specifically to attempt to decrypt the DES encryption, but it's still very popular. What is the DES algorithm in cybersecurity? The DES, Data Encryption Standard, algorithm is an encryption technique used to secure information initial permutation, IP. When we start encrypting information using DES, we first divide the plain text into smaller chunks of 64 bits. Next, the initial permutation, IP, is performed. Step 1, Key transformation. The DES uses the key of 56 bits. But this key is derived from a key of 64 bits by stripping off some of its bits. Step 2, Expansion permutation. Secondly, we extend the write plain text, RPT, of 32 bits to 48 bits. We divide the 32-bit block into 8 small 4-bit blocks. How does this work? The basic steps. 1. Begin with the 64-bit plain text. 2. Use the initial permutation, IP, to randomize the bits. DES encryption process, more details. 1. Key transformation, convert the 56-bit key into a 48-bit key. 2. Expansion permutation, convert the 32-bit RPT into 48 bits. DES modes of operation. The DES algorithm can be implemented in various modes based on how you prefer the encryption to be performed. Below are the 5 primary modes of operation for DES. 1. Electronic Codebook, ECB. Each 64-bit data block is encrypted and decrypted individually. 2. Ciphered blockchaining, CBC. Each 64-bit plaintext block is XOR-read with the preceding block's ciphertext prior to encryption. 3. Cipher feedback, CFB. The last ciphertext is applied as the input to the encryption algorithm, producing a new result that is thereafter XOR-read against the plaintext. 4. Output feedback, OFB. Likewise with CFB, except that rather than applying the encryption algorithm to the ciphertext, the algorithm applies it to the result of the preceding DES encryption pass. 5. Counter, center. A ciphertext block is XOR-read against every plaintext block, and the counter is incremented to produce each and every next block. Applications of DES algorithm. Even though DES is not commonly used in contemporary security networks because of its comparatively weak 56-bit key, there are a few areas where DES remains utilized, particularly in old systems. Some of these areas include: 1. Random number generation. DES may be utilized to create random numbers for different purposes, although it tends to be replaced by newer secure algorithms now. 2. When not so strong encryption is needed, for some situations where high security isn't required, DES can still be used because it's fast and easy to implement. 3. Triple DES, 3 DES. This is a stronger version of DES that applies the DES algorithm 3 times, using 3 different keys, which makes the encryption much more secure. 168-bit key length. Advantages and disadvantages of DES algorithm. Advantages of the DES algorithm. 1. Government standard. DES was made a standard by the US government, meaning it was well accepted and trusted for decades. 2. Faster on hardware. When applied on hardware, such as dedicated encryption devices, DES is quicker than software implementations. 2. This is the reason it was frequently utilized in systems where speed was a high priority. Disadvantages of the DES algorithm. 1. Poor security. DES has a 56-bit key, which is too small according to today's cryptographic standards. Therefore, it is susceptible to all kinds of attacks. 2. Susceptible to brute force attacks. Due to the tiny key size, DACE is vulnerable to brute force attacks, where the attacker attempts all possible keys until the correct key is discovered. With today's computing power, a brute force attack on DACE can be conducted quite easily. Why study DACE even if it's becoming obsolete? 1. Core knowledge. DACE was the first popular encryption standard and the foundation for contemporary cryptographic schemes. Historical perspective. DACE was a key component of cryptography in the 1980s and 1990s. Knowing its limitations and development is important in grasping today's cryptography landscape. Conclusion. The Data Encryption Standard, DES, was instrumental in the development of cryptography and the establishment of encryption algorithms used